Okay, we made it to the last page, and there are some doozy problems on here, so let's do our best to make Scratch work all over the place. Anyway, here we have our differential equation, and we have the slope field given to us already. So it says, sketch the slope field between 0, 2. So let's see, where is that? 0, 2 is right here. And if we follow these slopes, it looks like it might come down like that or something, and maybe come down like this-ish. Okay, a little bit of symmetry. So try to make sure it looks symmetrical on the left and the right, because the slope fields look like they're pretty symmetrical on the left and the right. So something like, yeah, that. All right. So now we need to find the solution. So this is our differential equation, right? So we have to find the solution given the point 1, 0, x is 1, and y is 0. Okay, and this is where the doozy part comes in. Okay, just to let you know. So we're going to separate our variables. So we have dy over y minus 4 cubed equals 1/2 of x dx. Remember, try and keep the number on the x side. It might be a little easier later on. Okay, so here we have this. Now we're going to anti-differentiate. So remember, this on the left can better be written as y minus 4 to the negative third. Okay, so when we anti-differentiate this, it becomes y minus 4 to the negative 2 divided by negative 2. Okay, so that's what the antiderivative of y minus 4 to the third is going to be. It's going to be y minus 4 to the negative 2 divided by negative 2. Okay, and on the right side, we have 1/2 of x to the squared divided by 2 again, right? Because we raise it to the second power, so we're dividing it by 2. So let's see if we can make this a little bit simpler. I'm going to take my negative exponent and put it back in the denominator. So that's 1 over negative 2y minus 4q squared equals x squared over 4 plus c. Okay, there we go. Now let's plug in the initial condition. X is 1 and y is 0. So we're going to put a 0 here. We're going to put a 1 there. And let's see what we get when we do some simplifying. 1 over negative 2 times 16 equals 1/4 plus c. So negative 1/32 equals 1/4 plus c. So then we're going to subtract 1/4 from both sides. Now I have to have the same denominator, so I'm going to multiply by 8. So I have a denominator of 32. Okay, so that looks like negative 9 over 32 is my c value. Negative 9 over 32. All right, so what to do with that? So I'll find this solution to y equals f. Now we have to solve it for y. Okay, once again, this is all of our algebra. So let's see. Negative 1 over 2 y minus 4 squared equals 1/4 of x squared minus 9 over 32. Okay, so let's get rid of the 32. I'm going to multiply everything by 32. Let's see what that does, right? Because I want to get rid of these fractions. So this is now a negative 16 on top and a y minus 4 squared. And this is 8x squared minus 9. Okay, to me, that looks much simpler. So now I'm going to do some switcheroo. I'm going to take this denominator and switch it with this numerator, right? So I am multiplying everything by this y minus 4 squared, and then I'm going to turn around and divide everything by 8 squared minus 9. Okay, so these are going to do the switcheroo. Square root of 16, 8x squared minus 9 equals y minus 4 squared. Okay, so now you can imagine we're going to take the square root of both sides. I'm going to come over here so that I don't run into my next problem. So square root of negative 16 over 8x squared minus 9. So as long as your denominator is negative, that's not going to be a problem with the negative on top. Equals y minus 4. Okay, so there would be some domain restrictions in here, of course, so that we actually get a positive value for a square root. And then I'm going to add 4 to both sides. So 4 plus and minus the square root of negative 16 over 8x squared minus 9. So the question is it a positive or is it a negative? Right? Is this the plus or is this the minus part? So let's go back and look at our graph. Okay, and which ways do the arrows point for your graph? And I think that's a fairly rhetorical question because the arrows are both pointing down. And if we have a even polynomial with the endpoints pointing down, that means it has to be a negative. Right, so we're going to pick the negative part of this, not the positive part. Right, so we can erase the positive. Where's my eraser? There it is. I can erase the positive, and we get 4 minus root of negative 16 over 8x squared minus 9 as the final answer to your equation. Okay, like I said, a lot of algebra. Okay, 24 is just the same thing. A lot of algebra to solve this differential equation. So notice that both of these terms have an x in it. So I'm going to factor the x out so that I have multiplication, right? I don't want to have to do anything with addition. I wanted to use multiplication. Because now I can separate my variables and get 1 plus 2y on the left side, and I have x dx on the right side. Okay, so if you don't have multiplication already, you need to change your problem into a multiplication problem somehow. And a good way to do that is by factoring. Okay, factoring out or factoring something. So now we're taking the antiderivative. Hopefully you know this is right, we could use u substitution. We can call that u, but maybe you've had enough of these where you know that this is a natural log antiderivative. And if we have a 2y, right, we have a 2y as part of your argument, we need to have a 1/2 in order to counterbalance that. Because our derivative didn't have a 2 there, it had, right, it cancels out with each other, right, so they're gone. So 1/2 of natural log of y plus 2y, 1 plus 2y, equals 1/2 of x squared plus c. So now we're going to go ahead and solve this equation for c by plugging in 0 for x and 1 for y. So 0 for x and 1 for y. And let's see, what do we get? We get 1/2 of the natural log of 3 equals c, because all that's gone. So if I take this up here as a 1/2 power, that becomes the natural log of root 3 as your c value. All right. 1/2 natural log 1 plus 2y equals 1/2 of x squared plus the natural log root 3. Okay, so our algebra, multiply everything by 2. Man, there's a lot of algebra in this unit. So ln 1 plus 2y equals x squared plus 2 ln's root 3. Well, that's kind of nice. Guess what? We're going to take this 2 here and we're going to make it into a power of 2. We're going to square that. So the squaring and the rooting goes away. Excellent job. So ln 1 plus 2y equals x squared plus ln regular 3. Okay, the 2 as a multiplier becomes the power of your argument, and root 3 squared is just 3. So now, when I exponentiate both sides, okay, things will work out much better, I hope. All right, so these are gone, and I have 1 plus 2y equals e to the x squared times e to the natural log of 3. Okay, remember when we have a plus as the power, we can split that into the product, or two products of the same bases. And look how nice this is. This can actually cancel out itself. 1 plus 2y equals 3e to the x squared. Much better. So now we can minus 1 from both sides and divide by 2. So 3ex squared minus 1, all divided by 2, so we can 1/2 all of that stuff. And there you go. There's your equation. So much algebra. So much algebra. Okay, speaking of algebra, here we have a nice Newton's law of cooling problem. Okay, well, exponential law of cooling. So we're going to, first of all, split this, right? This is your capital T. So we're going to replace those two things there to find the general solution of your differential equation. Okay, so we have d capital T over 14 minus 0.01t equals 1 dt. Okay, pretty easy stuff. So we're going to let u be this denominator, 14 minus 0.01t. So then the derivative is negative 0.01 d capital T, right? Capital dt. So dt is du over negative 0.01. And if we have negative 0.01 in a denominator, right, that's 1/100th. So that's negative 100 du equals dt, right? So I took my fraction, my decimal fraction, and changed it into its reciprocal. Right? So 1 over 100 in a denominator is now 100. Okay, so let's do that. Where should I do that? So I'm going to replace this with u. So the integral of dt over u times negative 100 du. I guess we don't need this on top, do we? This is a 1, negative 100 du equals the integral of 1 d lowercase t. All right, so this is negative 100 natural log of u. Remember, u was 14 minus 0.01 capital T equals lowercase t plus some value c. And we want to solve this thing for capital T. Oh, okay, first thing, divide by negative 100. T plus c divided by negative 100. Okay, so I'm going to write this as just t over negative 100 plus some other value c, right? So this is a different value c. It's something divided by 100. So just to kind of keep my powers a little bit nicer, let's do that. Okay, so anytime we're multiplying by c, you can just take that out and write it as another one. So we're going to exponentiate both sides to get rid of our natural log. So 14 minus 0.01t equals, here we have 1e, negative t over 100 times, right? So we're going to multiply e to some other c. Right, so this is once again what we're going to call some random other c, right? Some 14th different c value, just so that we can keep our story straight. Okay, so we have c times e to the negative t over 100. Something like that. Okay, so now we're going to subtract 14 from both sides. pretty okay. And then divide everything by negative 0.01. In other words, we're going to multiply everything by 100, or negative 100, I guess, because we have a negative there. Okay, so then that's going to be some other random C value times 100 from before. Okay, but we're not really worried about it because we don't have an initial value. But we're going to multiply that, and this is now becomes a plus, right? Because a negative 14 divided by a negative 0.01 is a positive 1400. Okay, so there's your t value, ce to the negative t over 100 plus 14. Whew. So now we have your initial condition. Let me write that down again. T equals ce to the negative t over 100 plus 1400. So now we know that at 0, right, when little t is 0, big T is 0. Okay, so this one is basically going to be 0, right, because that's e to the 0, so that's 1c, right, 1c. So the e part is gone. So c is negative 1400. So now we have the value of the constant. Okay, so our function t looks like 1400 minus 1400e to the negative t over 100. We want to know if it's unsafe, if it's left burning forever, if it goes above 1500 degrees. Okay, so let's do some evaluating here for a second. 1400 times e, we can write this as 1400 over e to the t over 100, right? Because it's a negative power, we can put it in the bottom. Now let's just think about this for a second. E to the t over 100, right? When after 100 whatevers, right? This is going to be e to the first power, so 1400 over e, and then maybe t is 1000. So that's 1400 over e to the 10th, right? So your denominator is getting larger and larger and larger and larger, and your numerator is staying the same. So this term is getting smaller and smaller and smaller, right? This term is getting smaller. So it's 1400 minus something that's getting smaller, which means it looks like 1400 is going to be the maximum that this is going to happen, right? The maximum. So if we were to sketch a little graph, if we start out at 0, right, we're going to get pretty hot pretty fast, but then after a while it's going to taper off, right? And it's going to grow less steep, less fast. The rate of which the temperature is increasing is going to slow down. Okay, in fact, this capital thing is 1400. That's going to be the upper limit of your temperature, 1400. Okay, so what we can do mathematically is we can take the limit as t goes to infinity of, well, maybe not t, maybe it's little t, right? Not capital T, but little t. Little t stands for time. So as little t goes to 100 of our big function, right, that equals 1400. That's the limit. That's the number that our graph is approaching. So 1400 is, of course, less than 1500. So yes, this is safe. Okay, for all of those reasons. The justification is about the limit of this function. At the limit as time goes to infinity, right, left on continuously. So we always have it going, is always burning. The temperature will never exceed 1400. Okay, so we have an exponential graph with a reflection across the y-axis, or rather the x-axis, okay, which means we're going to have a numerical horizontal asymptote as the upper limit. Okay, so hopefully this has gotten you a little bit better at taking solving differential equations. Okay, most of your test is solving differential equations. There are a couple of questions about the second fundamental theorem, right, where we are replacing that, was back on page 2. So practice some of those also. Hopefully you're going to have a fantastic day and will do well on this test. All right, that's all. Goodbye.